Okay. Good morning, everyone, or hello. I know people are calling in from all over. I'm Catherine Barrett with O'Reilly Media. I want to thank you for joining us for today's webcast, iPhone Forensics Demonstration. It's presented by Jonathan Zdziarski, one of the original hackers of the iPhone and the author of iPhone Open Application Development. Before we start, I want to remind you that you can resize your screen image by toggling the actual size fit to screen box in the upper left-hand corner of your screen. If you're disconnected for any reason, you can log in and join the webcast again. We've muted the telephone lines to reduce the background noise during the presentation. You can submit your questions via chat, and Jonathan will answer as many of them as he can. The chat button is located next to the actual size toggle box in the upper left-hand corner of your screen. You may want to minimize the chat window or drag it to the side during the presentation so it's not a distraction. And now I'm going to turn the presentation over to Jonathan. Please allow a few moments while we make the transition. Okay, there we go.
Great, excellent. Maybe I can get this chat window to stay down this time.
Okay, and you may
hi,
want
everyone.
to speak up. Good.
Can you hear me okay, Catherine?
Yes, I can hear you fine.
All right, great. Thanks for attending this. I wanted to turn this into a more technical-oriented discussion as opposed to the last webcast that we had, which was more high-level in terms of development. The recent popularity of the iPhone has created a need by many to be able to perform lawful forensic examination of the device, and I found that the iPhone hacking community that is working on unlocking and jailbreaking and software development, surprisingly, has a lot of similarities in terms of the basic needs in terms of getting into the device. And the techniques that are used, some of which are destructive, I've also come to find that there are several non-destructive techniques that make it a very useful community to tap into for performing these kinds of forensics. And so I've put together right now we're up to 28 pages now, iPhone and iPod Touch forensics manual. And I've made this available freely to law enforcement. And if you're interested in a copy, all you need to do is email me from your law enforcement address, a .gov or a state address, just something that's verifiable. And I'll send you this manual back with all of the links to the various toolkit payloads and whatnot that you'll need. I'm not today going to go into extremely deep detail because a lot of the details that you'll likely be curious about by the end of this are all covered in the manual. What I will show you is some of the basic high-level tools that we're going to use, and we're actually going to break into a device and obtain the raw disk today. I've already seen concerns coming up about, how you feel about installing tools on a device just to perform forensic analysis. And so I'll just get right into it and start out by explaining how the iPhone is laid out on a technical level. Apple needed the ability to deliver very easy updates to the user without blowing away their music and whatnot. And so they've split up the iPhone into two separate partitions. The first partition is a 300 meg system partition, and this partition by default is mounted read-only. So no data should normally get written to this partition. It remains in a factory state until it's jailbroken by the user. The second partition is the user data partition, and this partition is the one that we're actually interested in. This partition is what houses all of the users' email databases, all of their pictures, anything that goes onto the device, including just basic configuration files, gets written to the second partition. And so what our goal was in putting together a forensic toolkit was to create something that was capable of installing onto the iPhone without destroying the evidence. In other words, without touching the second partition. And so everything you're going to see here installs onto the root system partition. And basically the approach we're going to take here, there are several different techniques that have been used to jailbreak the iPhone. The technique that I've chosen for today's demonstration and subsequently in the manual is what I consider to be the best practice for today, which is to convince the iPhone to boot an unsigned RAM disk. This RAM disk is a RAM disk that's prepared by the software that we're going to be using today. You can also create a custom RAM disk at your leisure. And essentially what we're going to do is we send this RAM disk and load it into the memory, the RAM of the iPhone, and then we instruct the iPhone to boot the RAM disk out of this portion of the memory that we've uploaded it into. From there, I've created a very basic toolkit payload. And what this is a collection of various open source tools that we're going to need to recover the raw disk image. OpenSSH, DD, Netcat, a few other tools are in this payload, which gets installed onto the root partition of the iPhone as the RAM disk is booted. And then from there, the iPhone reboots and brings up the SSH, which is what allows us to go in and fetch the disk image. Once we've got the disk image, there are some pretty interesting things that we can do with it. Now, I'll get into those as we get there. But I'll just get started here. And the tools that we're going to use today, we're going to bring up iTunes, as you can see, and you've got the phone recognized and paired. There is an open source tool named, well, it's not open source yet, but it will be soon, named iLiberty. It's a free tool that you can download. And what I like about iLiberty is that it implements this technique in a very clean and easy-to-use way. And I've got a slightly modified version of iLiberty, because by default, iLiberty installs what's called the installer application, which is a third-party community software installer. And in doing so, that actually writes to the user partition. We didn't want to do that. So I've modified iLiberty and provided a special payload, and you'll have access to those through the manual. It basically skips over the installer installation. User partition. Make it a... So I've modified iLiberty and provided a special payload, and you'll have access to those. I'm getting a terrible echo, Catherine. Do you hear that?
Yes, someone came in unmuted. It happens when we get a lot of people dialing in at once, so I muted them.
Okay. So anyhow, this is the iLiberty tool on a Mac, and we've loaded this up. Again, it says installer here, but what's actually happening is we're going to create a custom payload, and I've already prepared one that we're going to use today, and this again is up on the repository, which will be provided with this manual. And the Forensics Toolkit, as I said, is just a very basic toolkit consisting of SSH and whatnot. I'm going to basically select custom payload. I go to this toolkit, I browse. It seems that easy. And then you click the little Free My iPhone here. You know, the great thing is you don't have to sit here and hack on the phone to get it to do what you want it to do, because these tools make it so easy. So I'm going to show you real quick using the photo booth, and you can see now why I'm not in law enforcement. I'm much too ugly to be in law enforcement. And this is, it's a little reversed, but you can see that the device has booted this RAM disk. And now it's rebooting, and at this point it's going to be booting into the iLiberty payload distribution tool. It's essentially going to be uploading the custom payload that's built into the Forensics Toolkit. And this takes just a second. You can't really read it because it's reversed there for you, but it says installing Forensics Toolkit. At this point, the toolkit is being installed onto the root partition. Nothing's getting written to the user space, which is where the evidence is. You're generating SSH keys. It's going to reset the password to Alpine, which is the factory default, just in case the user had already jailbroken their device. And then within a few seconds, it's going to reboot back into normal mode. So I'm going to quit this now. You can see it's still working. Phase 2 is just completed in iLiberty, which is the payload installation. Now the device is rebooting. Once the device comes back up, we'll have a working recovery toolkit on the iPhone that we can use to grab this raw disk image. And we've already, in less than 10 minutes, we've already accomplished about half of what needs to be done with just these tools that have made it so easy to use. There's also a Windows edition available, and there's a different set of files that are used for installing this payload on Windows. But it's a very similar process, and that's been outlined as well with plenty of pretty screenshots and whatnot. So we're done with iLiberty. We're done with iTunes at this point, and we've got this kit installed on the device now. The next step that we're going to take is to SSH into the device, and I want to make sure that the networking is set up right. Make sure I have the right IP address. And I've done this a couple times before, so I'm going to delete my SSH key here. Accept the key. As I said, the default password gets reset to Alpine, and now we're in. And we're in the iPhone. The toolkit is obviously running. So how do we get this disk image? We've got right now this is a 4 gig device. It's got no Ethernet jack. It's got wireless, but it doesn't have any way to hook up. No USB. You can't put an external drive on. Obviously, you can't create a tarball, or you'll lose the evidence. So what we're going to essentially do is we're going to do a raw disk dump over Wi-Fi, and we're going to fetch the disk image wirelessly. Now, in order to ensure that the chain of evidence is preserved, you're obviously going to want to perform this over a secure, encrypted, and probably isolated wireless network. So essentially what we're doing here is we're going to tell our desktop machine, first we're going to grab the IP address, we're going to tell our desktop machine to sit here and listen on port 7000. And then we're going to pipe the output of that to a disk image named, I'll just call it rdisk0s2, which is the actual device name. And I'm going to tell it to sit there and listen. Now I'm going to tell the iPhone to send me rdisk0s2 and netcat it over the network to the IP address of my machine on port 7000. And if you sit there, you could watch that for probably, depending on the size of the disk, it's going to take maybe an hour or two to get all of that data across. If you're looking at a 16 gig iPhone, you're probably talking 3 or 4 hours to get that data. So rather than make you sit here and watch this, I'm going to use an existing 16 gig image that I've already downloaded from a test device. And you can see right here, rdisk0s2, it's going to be a little bit smaller, of course, than the device's advertised capacity because you're just grabbing that second partition of data. You don't have any need for that first read-only partition on the device. Unless, for some reason, you're looking to get the information that a user may have intentionally installed on a jailbroken phone, for example, if you're investigating software piracy, something to that effect. Of course, at that point, it's much easier to get into the phone, but you can grab it either way. In most cases, if you're just dealing with your average drug dealer or pedophile or whatnot, the user partition is all you're going to be interested in looking at. And most of you are probably already familiar with some of the forensic tools out there. And there are many good commercial tools that are capable of analyzing an HFS partition. Unfortunately, there aren't a whole lot of good open source tools. So if you're stuck using just what's out there for free, the best tool that I've been able to come up with in doing some research is Scalpel, which most of you are probably already familiar with, which is based on the Foremost tool written by a few special agents, I believe, for the Air Force. And we're using the stock Scalpel here. However, there are about a half a dozen additional file types that are specific to the iPhone that we're going to want to grab out of this disk image. Just to give you a couple of ideas of the kind of data that's out there, and I'll show you examples of this in a minute. You've got keyboard caches, you've got your basic images and whatnot, you've got voicemail files, you've got browser history, things of that nature, a Google Maps cache, whenever they do a map lookup. That gets stored somewhere. So I've got a custom scalpel.conf file here, and I've outlined all of the special file types and headers and footers and whatnot in the manual, so we don't have to worry about going through those here. But you use it basically just like you would use it to scalp any other file, and scalpel-c, scalpel.conf, and then your disk image. And of course, as you probably know, this is another time-intensive process. Scalpel just sits here and it's going to run through the entire disk image over the next hour or two and create an output directory from that raw disk image. So again, since most of you have told me you didn't want to sit here and wait for a couple hours to watch this, I've put together just a basic example set of output. And we pulled this just from a test device. I installed a few family pictures and whatnot on here. You know, and it's great that we've got all of these files, but we really have no idea what they do. And we also have no idea which images are valid and which ones are not valid. Catherine?
Jonathan, hold on a second. I had a
Sure.
glitch on my screen. I need to turn the presentation back over to you. Just let me find you on the list here. Sorry, everyone.
I can just go ahead and keep talking if you want, and I'll wait for this.
Okay, keep talking, and I will find. There's so many people logged in here.
All right, so as most of you are aware, Scalpel gives you a whole lot of data, but it's not always necessarily valid data. You'll receive a lot of image files that are not really images at all. And so part of weeding through this is to try and figure out what data you can actually use. There are two methods I came up with that I think are pretty useful, which I'll share with you here. The first one is to use a tool that's capable of reading a real image to tell you if it's a valid image. That will, at the very least, give you a handful of files that you should probably be looking at first. One of the tools that I came across was a tool inside an ImageMagick package. And ImageMagick is just an open source, free image processing suite of tools. And the tool, I believe I still have it installed here. The tool is called Identify. And Identify basically, almost got that? Oh, there we go.
Sorry, a lot of people on the
All right,
list.
we're back.
Thanks.
Nope, the script. And of just an example of what you can do is you can call Identify on any given file, and for example, Identify 997.gif. And it will read this, and you can see that it outputted that it's a GIF and gave you the correct resolution and whatnot. Based on return code, you can say, okay, well, if it's a successful run, then I can use the double ampersand here and, have it say good, right? Very, very simple stuff. So we write this little test script, and we can combine this with a find recipe to basically go through the directory and say, okay, show me all of the JPEG images and run it through my little test script. And then the test script from there will just take over, and it will either move or delete or whatever you program it to do any of the valid images that it finds. So there you've got a very simple way to just get a hold of the images that you really want to be looking at. And coming off of the iPhone, I found probably several thousand files that Scalpel had pulled out that were not valid images. Of course, that doesn't mean there's not valid data in them, so you're obviously going to still want to have a look at it. So what valid data did we get? Well, we've got a directory here, and for those of you who've never used a Mac before, one of the great things that I love about the Mac is its visual environment. And this is also made very useful in dealing with forensic analysis, because you can click this little cover flow button right here, and you can get an instant graphical representation of everything you're looking at. And I'll just run through some of it. Just a couple of test pictures that we threw up. These are particularly interesting, and I want to share these with you because every time the iPhone is finished with an application. If you're sitting in a web browser, for example, and you finish using the web browser, you push the home button. Well, one of the things we all love about the iPhone, of course, is that it gives you the cool little effects of zooming back to the background and zooming the next application forward. Well, in order to do that, the ingenious developers of the iPhone decided to take a screenshot of the very last image that was on the screen when it goes to zoom that away. And so what you're looking at here are screenshots of the last use of various applications, like you've got some web browser images, and then this is just a sample photo library and whatnot. All of this gets stuck somewhere in the deleted temporary space of the raw disk image. So even if you're unable to recover things like mail and whatnot that are relatively old, you may end up getting a screenshot of some mail contacts and whatnot. And I've deleted, any of the personal information, of course, that I've had on here. But there's one particular type of image that's interesting to look at. Of course, you're going to also get, just plenty of album covers for, you'll get one per song most likely. There it is. There it is. That's the album you really ought to be looking for right there. One of the best albums ever made. Anyway, so you can browse around here, and you can see also that you wind up with a lot of plain text files. There's a test shell script that I had created. Back here, you can see that the AMR extension is specific. AMR is an audio codec that was made the standard by many cell phone manufacturers for voice recording. And so the AMR extension is a voicemail file. And you can click on this. It will launch QuickTime here. I don't know if you can hear that.
Wondering if you're on your way home, but I guess you guys are still talking.
And so you can listen in on the voicemails. If you get a fragment of a voicemail, you can run it through some audio recovery tools and whatnot. Some of the other data, and this is where it gets a little cooler. User local sandbox is the DAT files that we recover here are actually dynamic dictionaries. That's what the iPhone calls them. What they essentially are is a cache of most of the words that you would type in. And the reason it does this is because it wants to learn your very specific words and, the capitalization, things like that. And so what you've got here are a combination of various blurbs that have been typed into email. You've got words that had been Googled. For example, EVO 500T right there I highlighted as the model of a particular bass amp I was looking at. There are words from, if you go to a particular URL, parts of the URL get stuck in here. Pretty much anything the user types at some point is going to go through the dynamic dictionary and get stored as a keyboard cache. The keyboard caches can be deleted easily enough, and they do have sort of a cycle that they go through. However, this particular cache was about 2 weeks old when it got recovered from the phone, and had long since been deleted. So it's definitely there for a while. And that's one of the great things I think about working with a solid-state device like the iPhone, is that it's really designed to minimize writes to the disk. The disk is only going to last through so many writes. And so it appears, at least, that in a lot of cases, the iPhone appears to almost write to different parts of the disk. And I'm not sure if that's intentional or if that just happened accidentally the way that the kernel was written. But a lot of the data, when you go to replace a file, for example, if you delete this cache and create a new one, it seems to get created in a different part of the device and spread that out a little bit. The other thing that you've got as an advantage to you is that the device itself is, for the most part, oversubscribed or undersubscribed in terms of capacity. People buy a 16 gig iPhone because they want to store 8 gig of music on it. You hardly find a lot of people who want to put 16 or 32 gig of music on a 16 gig iPhone and sit there and uncheck things and whatnot. It's possible. But regardless, when you get the music on there, that music stays there until you reset the phone and upload it again. So the rest of that disk is relatively stable, leaving the empty space for pretty much any extra data that you want to fit on it. Here's this is an email that had been recovered, and you can see it's in HTML in the browser right here, but it's also in plain text. You can see it pretty easily. And most email is stored in HTML on the device. So looking for things like HTML tags and whatnot can be very useful. This is a cached page from, actually, no, that's a cached email from a Google News alert that had long since been deleted. It's sitting on the device, and I think, I'm not sure if I hung on to any P lists, but one of the other things that you can pull out from this device is the vast number of configuration files. And no, I didn't hang on to those, probably because they had personal data in them. But there are various config files on the device, and I've documented some of those as well in the manual. And you can recall the full browser cache. The call history database is interesting because the phone itself only shows you through the GUI maybe 24 or so of the most recent calls, but it seems that the call history database just keeps storing them. I pulled out several hundred from a strings dump on the database. Some of the other things that it will store, as I said, the Google Maps cache. I can actually even pull the list up here and probably give you a more complete. Just 1 second here. Let's see, you've got the voicemail history, you've got a list of mail accounts that have been created to check and send email on the system. The individual map tiles for Google are stored in a cache, so you can actually get an idea of what it is that the person was looking at in Google Maps. If you're dealing with a stalker or a child predator or something like that, that may be important information. The dynamic text we've talked about, and there's a few more items on here, including the address book and whatnot. So there's a whole lot of data that you can pull out of this device. And the most important thing, of course, is to be able to get it in a way that doesn't corrupt the device. And this technique that we've outlined here works with any version of the iPhone software from 1.02, which is very old, to 1.14, which is the current release version. Come 2.0, there is another technique that is being investigated right now that does appear to work, that will work with that and all previous versions of the iPhone. However, the manual will need to be updated probably sometime in June or July when 2.0 does get released. So with that, I guess it would probably be appropriate to open this up for just some general questions, and hopefully somebody there is still awake. Catherine, you want to field a few questions?
Okay. I think that you addressed this at the beginning. The first question that I saw someone ask was just in chat. He asked, is there anyone else here that's apprehensive about installing tools on the iPhone just to examine it? And you covered that, didn't you?
Right, yeah, and that's one of the first things I took note of when I logged in here is the concern of modifying the device. And what you want to do when you use these tools, you want to make sure that you're using the customized versions of them, which have been modified not to make any writes to the device's user partition. Now, the interesting thing is just turning on the iPhone changes, I'd say it writes about 5K. Most of it's overwriting files, but it overwrites about 5K of data on the user partition just on booting the iPhone up, in other words, when you power it on. And so, of course, it's more advantageous if you want to get the purest dump possible to keep the iPhone powered on from the time it's seized, and that also involves keeping it charged. If you're going to do that and you want to get the most pristine copy, there is an additional payload that will install on the device and force it to mount that partition as read-only while you're doing all of your forensic work, your recovery and whatnot. That is, I wouldn't say dangerous, but it causes the phone to generally malfunction while you're doing it. In other words, the GUI doesn't come up. You can SSH into the phone, and you can grab the image and get out, and then you can put things back the way they were. But while you're using it in that particular mode, which I guess I would call paranoid mode, the device itself isn't usable from a user interface perspective. So you have a couple of different options. The technique that we discussed here accounts for making no writes whatsoever to the user partition, with the exception of what the iPhone writes itself on boot. If you absolutely don't want to make any writes, there's another payload that, and I can help you get that going if you're interested in that. The manual itself has about a page where we document every write that the iPhone makes on boot. And I wanted to do that because disclosure is, of course, the most important thing when you're involved in making changes to the evidence. And just walking into a crime scene, of course, you're already destroying evidence. So we've kept it down to zero writing in terms of the toolkit, which I think is a very good start. And we've documented everything else. So I think and you be the judge, you guys for the most part are the forensic analysts. I think that's very fair to be forthcoming about any writes that the device does. But again, if you're looking for something that absolutely will not touch the evidence, there are ways that we can set it up to do that as well.
Okay, and then a gentleman asked, he said, I'm sorry I missed this. He wanted you to repeat again why you would transmit the data wirelessly versus using the iPod USB connection cable. He just missed what you explained.
Right. The USB connection, and we've looked into that, it is possible, but it's a terribly ugly hack, and it doesn't necessarily guarantee the data integrity anymore. Essentially what you have to do to transmit the data over the USB is you're basically hijacking Apple's mobile device framework, and you are using it to get a raw device whose size is not being reported on the other end. So you never know when the end of that device node is. And you're also making some really ugly hacks to Apple's framework library to get that. It made a lot more sense to be able to transmit wirelessly because, number one, Netcat and DD are very widely accepted tools. And number two, you can pretty much choose what level of encryption that you want to incorporate to build a secure channel to transmit that data. When you're sending it over the USB, you have the advantage, of course, of being directly connected to the machine. My concern is all of the ugly hacks you have to do to get that off the device may make it appear to be less credible than transferring it wirelessly.
Okay. We have another person asked, what about the power on passcode?
Power on passcode, I believe, I haven't dealt with that directly, but I'm pretty sure that can be overwritten easily with a payload to overwrite that in the operating system. There are a couple of applications I've seen that users have set up to require a passcode, and then of course there's the SIM pin as well. If you're looking to take data off of the SIM, none of that is actually covered in this manual and this demonstration. SIM forensics have been around a lot longer, so from there I can't help you. In terms of actually getting into the device can be forced into recovery mode, which essentially is going to bypass any kind of operating system level security. And so from there, once you boot that RAM disk up, and you can create your own custom RAM disk if you like, but once you boot that RAM disk up, you're able to basically bypass anything else that you'd like to on the device.
And then one guest asked, is the phone still usable after it's been opened up this way?
It is, and in fact, there are a couple of different things that you can do once you've opened it up. You can either seal it back up, and no one will be any the wiser, and just hand it back. If you wanted to also, I've been tinkering with putting together a surveillance payload for warranted surveillance. That would most likely require a subpoena, or if you're a federal agency, maybe not. But there are a couple of tools that you can use to actually create the phone or create an environment where the device will call home, so to speak, and report whatever location data, browser data, whatever it is you're looking to report back to the user. So if you're looking to do a type of surveillance setup with the device, that's possible to do as well. But in either case, you can restore the phone back to working mode and remove the forensic toolkit very easily.
Okay. Jonathan, we're getting a lot of questions about your manual, and people are asking, first of all, how did they get it from you? And second, one person asked, will it be available to consultants who work strictly with commercial entities that work strictly for law enforcement?
Sure. Okay, well, first of all, to get the manual, if you are law enforcement, just send me an email at jonathan@zdziarski.com from your LE account. That can be a .gov. It can be some state.us. As long as I can verify somehow that you're a law enforcement officer, I'm more than happy to send it. The toolkit's free of charge. The manual's free of charge. Distribution within law enforcement circles is entirely unrestricted. There's nothing, basically nothing you can't do with that. It gets a little messier when you get into the commercial world, because I want to get these tools into the good guys' hands. At the same time, there are probably a dozen or so professional forensic software development companies who would love to take all of this work and just productize it and start charging for it. And so I've been trying to come up with a creative solution that would allow the good guys to get a hold of it, especially the ones that are doing consulting directly for law enforcement, without necessarily getting all of these ideas ripped off. And so I'm putting together something to the effect of a non-disclosure, a non-productization agreement, something to that effect. I've also been talking to a couple professionals in the field who might be able to offer some type of, I don't want to say commercial solution, but some type of system where the commercial companies that are wanting to do something with it can get a hold of it, and at the same time, do it the right way without ripping all of this research off. So, I guess for now, if you have a department that is entirely dependent on you as a consultant to do this forensic work, if you can have someone at the department vouch for you, contact me directly from their account. I don't foresee a big problem with doing that, as long as you're willing to sign something that says you won't turn around and turn it into a big commercial product. Like I said, my goal is to get it into as many people's hands as possible, so that you guys can go and do what you do best. I'm still working on that. If you have some ideas, you're welcome to send them by to me as well. But as of right now, if you are law enforcement, or if you can vouch for your forensic examiner who is a consultant, contact me, and I can put this in your hands today.
Okay, good. Let me see. There was another question from the DD of the iPhone. I don't know what that stands for. Can you distinguish between the files on the disk and files that have been deleted?
Very good question, and I failed to actually demonstrate this. I still have screen, right?
Yes, you do.
Okay. If you are on a Mac, this is actually very easy to do. All that's involved is to rename the file, or a copy of the file, that is, to a DMG, which is a disk image. And then at that point, you can go right to it, and you can mount it right in the Finder. And then from there, you can actually analyze the entire file system as it is.
I apologize for not showing that to you. And then from here, you're looking at what is mounted as private var, and private var mobile is where most of the user data is going to reside. And then from here, you can grab cookies, you can grab the call history database. All of the live files on the file system are immediately accessible to you. You can view them using the cover flow view, or however you want to do it. From a Windows machine, it's almost as easy. It takes a little bit more work. There is a tool called DMG2ISO. As DMG, the number 2 ISO, and basically you have to convert the raw disk image into an ISO image in order to mount it. And if you have a commercial tool that is capable of reading an HFS partition, you can mount it directly from there as well. So that will get you the live file system. In terms of determining what's deleted and what's not, you would have to probably go one layer lower and actually look at some of the inode tables and whatnot. I don't really have a straightforward solution for that, but chances are if you're looking to do that deep inspection, you've already got the tools that are capable of that.
Good. I don't think we have any more questions. Are there any more questions, anyone?
Oh, one other thing, don't lock the DMG. Operate on a copy of it. Your DMG should be checked into your digital vault at this point, and you should not be touching it from the minute you send it to your machine. So if you're going to mount this, locking is not a bad idea, but it's kind of a false sense of security. You really should be operating on a copy of this data.
Okay, and someone said, Bill asked if you could please repeat the DMG2 ISO information.
Right. Well, you can Google DMG2 ISO. You spelled it right, Bill. I believe it's just a Perl script. The two formats are apparently very similar to each other, and it just converts it from one to the other. Once you've got it in an ISO format, on Windows you can mount it with daemon tools or any tool that's capable of mounting an ISO image on your desktop. I believe there's a program called Forensics Toolkit that is a commercial tool that's actually able to mount the image as is as well. So that may be something worth looking into.
Okay. Any other questions? You're still getting a lot of questions about your manual. And I would say, rather than take up time with that here, if you have a unusual situation, feel free to email Jonathan and take the discussion up with him, because he can't deal with all the various questions about it here and may want to answer you individually.
Yep, no problem taking the time to talk to anybody. As I said, if you're commercial, at least get someone who's in law enforcement to vouch for you, and there may be some paperwork involved. If you're law enforcement, you won't have any problem getting it. I would say no to students at this point, or just anybody who's curious. I may release this to the public. These techniques may release them sometime later on, but for now I wanted to give law enforcement the first crack at having these tools. Once you release all of this to the general public, and I normally am a very open type person, as you probably know, I'm very active in open source, but normally when you release this kind of information to the public, the next thing you'll start see popping up are evidence erasers and things of that nature. So at the moment I feel that it's necessary to put some controls on it. But go ahead and email me if you've got some special one-off circumstance. I'd be glad to talk to you about it.
And we've just got a few other questions that came in. Let me see. Someone's asking if you have a forum and blog. And Jonathan, do you blog on your own site, Jonathan? There is a forum on the O'Reilly
site. I rant on my own site.
Okay, Jonathan rants on his own site, and there is a forum on the O'Reilly site, and Jonathan answers questions there. And I sent you the link to that in the email that I sent you yesterday or this morning with the login information for this webcast. And then, this is an interesting question Jansen is asking, has this been used in the field yet?
It hasn't made it to court yet. It's only actually been around for a week or two. I've just started circulating it. It started out something I was sending manually to people that I knew who were in the field. With that said, I have been talking to one particular forensic agent who has been gracious enough to give me his time in trying to validate all of this, and he's given me a lot of great input that's made it into recent drafts of the document. David Graham, who is with the Virginia Attorney's Office, he's continuing to work on validating it. He's gone through the Windows process and whatnot. As he has access to a lot of resources I don't, I'm hoping that he can also help to further refine this if it needs refining, to make sure that the techniques are rock solid in terms of being admissible. And we've gone through just some free tools here in this demonstration, but for those of you who are getting the manual, I've included source code examples and real low-level techniques so that someone who needed to could reproduce these on their own without these tools. Tools are great because, as you saw, the first 10 minutes we had cracked into the device. But when it comes to actually showing the techniques in court and making it so that a low-level engineer or scientist can understand them, I've included a lot of that information as well. And there's source code you can compile right from the document to upload a custom RAM disk and execute that in memory and whatnot. So it's all fully disclosed in the manual for you.
Okay. We got a slew of other questions, and I don't know, do you have time to answer them now, or would you rather... Shall I read them to you, Jonathan?
If there are people that are willing to listen to me rant for another 10 or 15 minutes, sure, I'd be glad to put the time in.
Okay, all right. Then one question, one person is asking, does iLiberty reset the power on passcode?
The answer to that is I don't know. I've not had a device to test that has been passcode protected yet. But that's a very good question, and I will have an answer probably by the end of the day.
Okay. And then can you circumvent the user lock code? Is it stored in a file?
Well, there are a number of different types of locks on the device, so I want to make sure I'm addressing the right ones. The SIM lock can be defeated in terms of recovering the phone. The SIM lock can be deleted by putting a different SIM in. In terms of, or actually it may even, if you choose to activate the iPhone, you can even do it without a SIM. There are a number of operating system level locks that I've seen. Some of them are, I believe there's at least one built into the iPhone, and then there's another one that's a third-party application you can run. All of these are operating system level locks, and those are entirely ignored, and you'll get in through the back door before you even have to deal with those locks. If there's some other lock that someone's curious about, I may not have heard of it, send me some information. I'll be glad to investigate it. At this point, though, we've gotten down to the boot level, the bootloader level on the device, and making changes to the baseband and the bootloader and all of these other low-level components. So I would say that there's a very strong likelihood that any kind of protection could be defeated. And that's one of the things that the iPhone development community has really come to benefit you in terms of these uses, is all of the efforts to unlock the phone and all of the efforts to put third-party applications on the phone since the iPhone's release last year have led to most of the techniques that you're seeing used in this manual today. And so as avid enthusiasts of the iPhone continue to hack away on newer models of it, we're going to be able to take some of these techniques and work them into a solid forensic solution that works for law enforcement.
Okay. And then let me see. One person's asking, is the read-only portion of the phone offered up as a splice that can be located within IOReg?
You can see the device. You can see the disk device in IOReg. If it reports, I'm not sure if it reports on slices or not, but if it does, you should see it there. The two slices are actually just your standard partition table. And if you use a tool like fdisk, you'll be able to see both partitions. In fact, prior to coming up with this RAM disk technique, the technique that had been used prior to this involved doing a dual boot, which was really cool, in that you would set up a third partition on the device and install your payloads on that partition, and then you would boot off of that after you did, say, an update of iTunes, an update through iTunes. And so you'd actually be able to create and boot off of additional partitions on the device. That's entirely useless and reckless for forensic work, but in terms of getting into the phone, it worked fantastic. So it's very standardized is what I'm saying. The partition table is going to show up just like a regular Mac desktop partition table would. It's all a matter of just having the right tools, having them built specifically for the ARM architecture. And you can, if you've got some open source tools that you need to stick on the iPhone for any particular purpose, there is an open source toolchain compiler available for the iPhone. And I actually did a demonstration a couple of weeks ago with you, Catherine, and I believe that's available on O'Reilly's website as well, isn't it?
Yes, it is. If you can just Google for it, or you can go to our site, and I posted it we have it posted on our site, and I believe, I'm not sure where the link is, but I blogged about it on the O'Reilly FYI blog, so you can find it there.
Excellent.
And
so,
anyone who wants a link to the previous movie, just if you want a link to his last demonstration, just email Webcast at O'Reilly, and I'll send it to you. And did you see this error about scalpel on your screen? Jonathan, someone's asked, he says that he or she, I don't know which, said that he got this error working with scalpel, and then the error is, if you scroll up in your chat box, you'll be able to see it.
Yeah, I just responded to that. If it's
okay, good.
If it's not a disk space issue, if you're not full, then I sent him a ulimit command that he can run.
Okay.
That may, if it literally means he's out of file descriptors, then that would fix him. You may also want to run it as root, or just run it as root and then ulimit again. I haven't run into that problem with Scalpel, but the first demo I did to get these files, I used Foremost. So if you've got the time to sit down and have a cup of coffee, you can try Foremost instead. It's a lot slower, but it seems to work just as well.
All right. And
well, I think folks are starting to wane off now. So
okay.
I appreciate everybody's
so
time and just coming to listen to me show you a couple of neat tools that came about from the open source community and from the iPhone hacking communities and whatnot. It's really exciting to see that some of this technology has actually been applied for purposes that are making the world a little bit of a better place. So if you have any questions, feel free to email me. If you want a copy of the doc, shoot me an email from your law enforcement account, and hopefully this benefits you. I would love to hear about it if this actually does make it to a courtroom somewhere. And if you're interested in participating in maybe validating or improving on some of this, also please feel free to contact me.